This section is on the chi-square test for goodness of fit. So in this section, we will learn how to test if a list of observed, or actual outcomes, fits a list of expected, or predicted outcomes. And we will be using lists on the calculator for this chi-square test. The observed frequency list O is the list of observed frequencies, which is what actually happens. The expected frequency list E is the list of hypothesized frequencies, which is what is expected to happen. So the chi-square test for goodness of fit is used to test whether an observed frequency distribution fits, which means is the same as, an expected distribution. So this is a hypothesis test, which means we can use rejection regions or p-values. So using rejection regions, we first have to verify that each expected frequency is at least 5. Then state the claim. Now, the null hypothesis and alternative hypothesis always say the same thing. So the null hypothesis always says the observed frequency distribution is the same as the expected distribution. And the alternative hypothesis always states the observed frequency distribution differs from the expected distribution. Next, we have to identify the level of significance, the degrees of freedom, and the degrees of freedom are equal to k minus 1, where k is the number of categories, and the critical value. And again, the chi-square test is always right-tailed. Next, we have to calculate chi-squared, and that's equal to the sum of the observed values minus the expected values squared divided by the expected values. Now, the rest of the steps are the same as all of the other hypothesis tests that we've done. And we will not be solving by hand using p-values, but we will be using p-values on the calculator. A retail trade association claims that the tax preparation methods of a sample of 300 adults should be distributed as they are in the third column. So that's what's expected to happen. Now, a tax preparation company randomly selects 300 adults and asks them how they prepare their taxes. So the actual observed results are listed in the second column. At alpha equal to 0.01, test the Retail Trade Association's claim. Use the rejection region method and show all work. Now, first we need to verify that each expected frequency is at least 5. So all of these numbers are at least 5. So the claim is the observed frequency distribution is the same or close enough to the expected distribution. So this is the null hypothesis. The alternative hypothesis is the observed differs from the expected. So alpha is 0.01. The degrees of freedom are equal to k minus 1, where k is the number of categories. So we have 5 categories: accountant by hand, computer software, friend or family, and then a tax preparation service. So the degrees of freedom would be 5 minus 1, which is 4. And then our critical value is 13.277, so we have to refer to the table. Now for chi-squared, we want to take the observed value, subtract the corresponding expected value, square it, and then divide by the expected value. And we have to do that for all of these. So it's a large calculation. Now I'm going to type that all in one line on the calculator. So that will look like this. and it's equal to 16.958. So the picture would look like this, and chi-squared would go right there. So chi-square is in the rejection region, which means we reject the null hypothesis. And the conclusion would be, at the 0.01 level of significance, there is enough evidence to reject the claim that the observed distribution and the expected distribution are the same.